split 2x squared minus 21x minus 16 over x minus 2 times 2x plus 1 all squared into partial fractions, and then hence integrate the same function. Okay, if you were just given this, you would have to split it into partial fractions. So, writing down our algebraic fraction, this can be written down as a over 2x plus 1. It's a repeated linear factor, so you also have to have b over 2x plus 1 squared plus c over x minus 2. Right, in order to have the same denominator on the bottom, then that will mean that 2x squared minus 21x minus 16 would have to be equal to a times another 2x plus 1 and a x minus 2. The b would have to just be multiplied by an x minus 2, and the c would have to be multiplied by 2x plus 1 all squared. And then what we can do is we can put x equal to 2, because that will make that 0 and that 0, and that will give me the c1. If I put 2 in here, I'm going to get minus 50, and then if I put 2 in here, I'm going to get 25c. Therefore, c is going to be minus 2. And then the next thing I'm going to do is put x equal to minus a half, which will make that 1 and that 1 0. And therefore, we're going to get minus 5 is going to be minus a half minus 2, which is minus 5 over 2b. And therefore b would have to be equal to 2. Now, in order to find a, I would have to equate the coefficients of x squared. So there's a 2 here. Here there is a 2a, because it will be 2a times 2x times x. That will give a coefficient of 2a. There will be no x squared term here, but here there will be a 4c, because when you expand this, you're going to get 4x squared times c. But we got the value c, it's minus 2, so that means this becomes 2 times equal to 2 times a, 4 times minus 2, which is minus 8. Therefore, 2a is 10, and a is plus 5. Right, we need to write this out, putting these values in instead of a, b, c. So now putting our values in. So notice here the sign would change because it's minus 2. And then we now need to integrate this function by integrating all these terms separately. Okay, so set the integral up correctly. So the first one is just going to be 5 ln of 2x plus 1. But if we differentiate back, we're going to get an extra 2, because this would be 2 over 2x plus 1. So we'd have to put a 2 in here to compensate for that 2. This one's a little bit more tricky, because this is like 2 times 2x to the plus 1 to the minus 2. So if we just try d dx of 2x plus 1 to the minus 1, which is one more power than that, differentiate back, we're going to get minus 2x plus 1 to the minus 2, and then when we differentiate the bracket, we get 2. Which means I got minus 2 over 2x plus 1 squared. But I didn't want minus 2, I want plus 2 over it. Therefore, I need to change the sign of this and make it negative. So this will be minus 2x plus 1 to the minus 1, which we can write as minus 1 over 2x plus 1. And this one's fairly straightforward. This is just minus 2 times ln of x plus 2 plus a c. Now we can combine the logarithms. So the logarithm will become, the minus between the logarithms will make them be a division. And then we're raising this one to the power of 5 over 2 and this one squared. Okay, so you can't take the square root of a negative number here, so this would have to be all positive. So we don't really need the absolute value signs. And then we've got a minus 1 over 2x plus 1 plus c. So this has been a video to show you how to integrate a function which needs to be split into partial fractions. I hope you've understood, and I thank you very much for watching.